Hi everybody, welcome back. So this time we're actually going to learn how to use dimensional analysis to help ourselves in our equations. So let's look through it. The first one is called the plus law. It means every term in your equation has to have the same units. Same dimensions. If it doesn't, it's not a real equation. I love to say that this is the law that helps you the most when you are trying to do something from memory. Because some teachers let you have equation sheets and some don't. I'm one of those teachers who lets you have an equation sheet because this is an online class in series. Like, come on. Everybody uses equation sheets. You always have reference manuals. But some don't. And so you're like, oh, wait a second. Was that squared? Was it cubed? Oh, I can't remember. Was it velocity squared or cubed? Well, you can use dimensional analysis to help yourself. Because if you look at your equation, every term should have the same dimensions. So like for example right here, surface area. I've got length times length, this is good. Length times length, that's good. And if for some strange reason I had length cubed here, that would be not good. I realized, okay, I've got an extra distance here. Oh, it wasn't cubed, it was squared. Boom, answer solved. So every single term in your equation has to have the same dimensions for it to be a real equation. Be very careful though, because if you see a derived dimension in there, well, there's Newton meters, but this one over here is kilogram meter squared per second squared. I guess it doesn't work. Remember that derived dimensions are made up of base dimensions. This only works with the fundamental dimensions, so make sure you break it down. Okay, now the unit law. It says that you can't add or subtract anything if they don't have the same units. Because if I have one, let's make it a little bit easier. If I walk 1 mile and then you walk 1 inch, we can't add those together and say, well, we went 2 miles? No. We went 2 inches? No. We went 1 mile and 1 inch. So we'd have to convert to the same unit to be able to add those together. Convert to the same unit to add those together. For example, 1 yard plus 1 foot is 1.33 yards, not 2 yards, not 2 feet. So this is more of those just check yourself. Make sure that you actually have the same units and you've converted everything properly. Otherwise, you're going to have a lot of pain at times. The last thing is to multiply or divide. You just treat dimensions and units the same as numbers. So you can divide them, you can multiply them all the way across. They're just like numbers. Use them like variables, use them like numbers, and you'll be good to go. While you're doing that, it doesn't matter if they're the same unit or not. You can divide miles by meters. At some point, you're going to want to convert to the same units for everything, but when you're starting off, it might be easier to simplify by just going ahead and dividing and multiplying. So look at that and see if that can help you. Remember, right here, if I don't have the same units, I can't add them together. But all of these have the same dimension. And one last detail, okay, is if we go back to our plus law, I said every term in an equation must have the same dimensions. But even if they all have the same dimensions, that does not mean that we've passed our unit law. Doesn't mean we passed the unit law. You might still have to go and convert things. Dimensions are much more general. Units are how we get down to the brass tacks and decide, okay, what amount of that dimension do I actually have? So make sure you don't get confused. Okay, now these 3 laws are extremely helpful, especially as you start getting into those physics classes. So please remember them and use them to your advantage. Well, I hope this helps you, and I will see all of you next time. Bye-bye.